Welcome to Unit 3 on functions. You now have Mr. Orgak to listen to for the next 2 weeks, so enjoy. Functions basically, like it says, are a rule that says that every input has exactly one output. So that's the big key that you have to have, has one and only one output. And that's where we're going to go. We're going to take a look at functions in the forms of graphs, equations, tables, and descriptions. In our first unit here, lesson 1, we need to fill in this function table where it says, let's multiply the input by 2 and then subtract 1 to get the output. So all you have to do is take this 0, take a 2, times the 0, and subtract 1. Well, we know 2 times 0 is 0, minus 1 gives me an output of negative 1. 2 times 1 minus 1. You take 2 times 1 is 2, minus 1 is 1. 2 times 2 minus 1 gives me 4 minus 1 is 3. And 2 times 3 minus 1 gives me 5. Then they said create a rule for this. Well, what's going on every time? Well, what am I doubling? I'm doubling the x part here, this input piece that we just did. So all you have to do for your function, remember the old equation, y equals, well, what's happening to x? You're doubling it. And what's happening every time? You're subtracting 1. That will be the function rule for this. In part C here on our first example, we now have to create the graph. So all you need to do is take your table from the last one. You started off with an input of 0 and you hit here at negative 1. So I'm going to put a point there. Then you had an input of at 1, you were up 1, so I put a point there. Then you were at 2, up 3. And then we were at 3, up 5. The last thing you need to do is obviously connect the line and put your arrowheads on. You have now created a function. You know it as a linear function from last year. That is your line. Alright, now in exercise 2, we are to take the function y equals 2x minus 1 that we wrote in part 1 and actually find an input if they give you the output already, the y part. So the first thing you're going to do is you're going to write the 17 in for the y, and that's going to be equal to then the 2x minus 1. And then we're going back to our last unit, just solving the equation, nice two-stepper. So move the 1 from the right side to the left by undoing it on both sides. You'll get 18 equals 2x. And of course, to get rid of the 2, we have to divide because it's connected by multiplication. So divide both sides, and your answer turns out to be 9. So we should have an input of 9 whenever you have an output of 17. You'll now move on to the next exercise. Okay, in exercise 3, we got a new function rule. It says basically to convert into an output y by increasing 1/2 the input by 10. So we're going to write an equation here and set it up, and basically it says we're going to take 1/2 whatever the input is, and the input here is 50, so I'm going to take 1/2 of 50, and it said to increase it by 10, so you know that means to add 10 to it. Well, what is 1/2 of 50? All we're doing is the math here, nice and easy. That's 25 plus 10. So our answer to this one would turn out to be a 35. So if my input is 10, there's my output, a 35. Now they said to write an equation for this. Well, we basically just wrote it right above us here. All I have to do is replace that piece, the 50, which is my input, by what variable? Well, it's the x. So I know it's 1/2 x, and I'm adding 10 every time. So half whatever the input is and adding 10. And to write it as an equation rule, we have to have an equals. And that could come in the form of y equals. They might call it something like f of x equals. Same thing. So the function rule here now says basically f of x equals 1/2 whatever the input is plus the output of 10. And that is your function rule. So now we'll move on to the next exercise. Alright, now in exercise 4, basically tell you is function rules do not have to have numerical values basically in nature. They can just simply have some sort of a relationship where each input has exactly one output. And if you look at this table here, we've got child versus month, so we've got kids like Max, Irvin, Zeke, Rosie, and Nico. And on yours, much clearer than mine picture here, you've got months that come in January, May, February, all that good stuff. So question A here basically states, why can we consider this a function? Well, what's the reason why? Well, basically it's because each child has exactly 1 month that they're attached to for their birth month. So Max has January, Irvin has April, and so on. So that is what we have as far as it goes. So that's your answers for part A. Each input has exactly 1 output. Each child has exactly 1 birth month. And that's what you would write down on your paper. Okay, now we go to question B here. It says, what is the output for Rosie? We'll take a look at Rosie. Here's Rosie right here. What's her output? Pretty straightforward. Her birthday month is February. That's her output. That's when she was born. So that is your output for Rosie. Part C, find all the inputs in the given month for an output of May. So if I take a look again, I'm looking for May. Well, I see a May right here. Who has it? Zeke. I also see a May right here, which is Nico. So which inputs had an output of May? Well, bottom line is your answer is going to come down to, you need to write down it was Zeke and also Nico. Both had outputs that were born in May. And that is another way of doing functions without any numbers involved in this thing. We'll now move on to exercise 5. In exercise 5, basically, we're going to take a look at Charlene, who heads out from school on foot one spring day. Her distance from school is in blocks, and we'll have that along the vertical axis. That's our distance, versus the function of time, which is down below here in the bottom, and that's going to be in minutes. So we're going to take a look how far basically from school she is as she's walking. Well, question A basically now takes a look at this graph and says, how far does Charlene start off from school? We'll take a look at, where does she start off? She's up here. You're taking a look at that. So since this is worth 20 here, and if you look at each block, each one is worth a value of 2. I've got 5 blocks for 10, so if you divide 10 by 2, you get, by 5, you get 2 for each block. So each unit's worth 2. So here's 20. Go up 2 more, and we will have our answer called 22 for part A. Now part B says, what is her distance from school after she has been walking for 4 minutes? Well, I have to take a look again down here. 4 minutes means coming down here, 1, 2, 3, 4. I'm going to go all the way up and hit here. That's where the 4 minutes hit, so where did that turn out to be? 2 blocks above 10. Each one's worth 2, so our answer obviously is 14 blocks. Okay, so that'd be your answer for that one. Part C says, after walking 6 minutes, Charlene stops and looks for her subway pass. How long does she stop for? Take pause for a second and then come right back to me and see if you can figure out that answer. Now for me, I'm going to take a look here. It says after 6 minutes, so that's over here. I'm going to go up here, and then it says how long does she pause for? Here's the pause. Notice, we're not going any further in distance. She just paused there. That's worth 3 blocks. How much are each one of these worth? A minute apiece. There's only units 1 each down here. So what is our grand total answer here? She paused for 3 minutes. That's the time from here at 6 seconds till she got to 9 seconds before she started walking again. Okay. Well, 2 more questions, sorry. D says Charlene then walks to the subway station before heading to school, or the local subway. How many blocks did she walk to the subway? Well, once again, we're going from where she last paused right here, and we're going to go up to this point right here. Well, what did she have to do? She walked 2 minutes worth, but how much is this height? Once again, it's only 1 block that she actually walked at this point. So what is 1 block worth, or one unit here worth? 2 blocks over here on this thing. So that will be our answer, would actually be 2 blocks is what she walked to get to the local subway station. Right? Final question, how long did it take her to get to school once she got on the train? Well, once again, where did she get on the train? She got on the train basically right here. She ends up down here. Well, what do you have? You've got 15 going back to, what was this? This was at the 11-minute mark. So they want to know time, so we're here. We're not looking at blocks going up and down. We're looking here where she started to walk towards the train, or on the train, until where she got home right here. So what do we do on that one? Well, we take the 15 and you minus the 11 that she started at, and your answer is basically 4 minutes. Okay? So there's functions, reading a graph. Once again, the highlight for today is you need to know that function is a matter of an input versus output, and every x value, that's your input, always has one and only one y value, and we're going to get to that in future lessons. But that's our thing here today. Can you read a graph and interpret everything that we're asking for you as functions of an x, which is your x-axis, versus your y, in a table, and an equation. So until next time, take care. Write a good WSQ now, and make sure your notes are completely filled in on this lesson. Thank you.